Hey guys, so today what we're talking about is prime factorization. Okay, so basically you're breaking down a number so that you get that number to have multiplication using prime numbers to get that number. So remember guys, prime numbers are when the number, if a number is prime, the only two factors for that number are the number 1 and the number itself. Okay? So, we're going to go through some notes here together. First question here, what is the difference between a factor and a multiple? All right, so factors are what we can multiply to get a number. So let's write this down. Factors are what we can multiply by, or what we can multiply to get a number. Okay? So remember guys, you can pause this if you need to write for a second. So factors are what we can multiply to get a number. So for the number 8, your factors are 1, 8, 2, 4. Those are factors, okay? And you're using a T-chart to figure out what those factors are. Now, when you talk about multiples, you guys should all know this. Multiples are what we get after multiplying the number by another number. So let's write this. Multiples are what we get. Hopefully you guys can read this here, okay? I'm trying to zoom in. Or what we get after multiplying the number, I'm going to use a hashtag, the number by a number. Okay, those are hashtags for number. Okay, so multiples, go ahead, underline this part, factors, and here's multiples. So that's the difference between the two. Multiples are what we get after multiplying the number by a number. Okay? Pause if you need to at any time, guys, so you can write this down and then come back to the video. The prime factorization of a number is the number written as the product of its prime factors. Okay? So remember, prime means the only factors are 1 and the number itself. So 1 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number. Okay? The number 6 is not a prime number because 6, you have you have factors of 1, 6, and 2, and 3. So it has 4 factors, it's not a prime number. Okay? Prime numbers only have 2 factors. All right? So prime factorization is usually written as a numerical expression using exponents. So this is what we looked at yesterday, exponents. Okay? Exponents. For example, 2 times 3 times 3 can be written as 2 times 3 squared because we have 2 3's here. 3 is the base and 2 is the exponent. All right, so notice here, guys, 2 times 3 times 3, you can rewrite it as 2 times 3 squared because the 2 exponent of 2 means the 3 repeats twice. Okay, so you have 2 3's here. All right. The exponent tells us how many times the base is used as a factor. All right. The exponent is 2. That means I'm going to have the base of 3 is going to be written twice. There are 2 3's, so the exponent is 2. All right. So what we're going to do here is find the prime factorization of 28. All right. So there's 2 ways you can do this. You can use a ladder diagram or you can use the tree diagram. All right, I like to use the tree diagram, so let's do the tree diagram first. Okay, so you start out with the number 28, and you're going to break it down like you're making a tree. Okay, think of two factors you could multiply times each other, so you're going to get 28. So two numbers you could do are 4 and 7. All right? Now, 4 times 7 is 28. That's why I chose 4 and 7. Now, between these two numbers, you have to think about which one are either one of those numbers prime. If they're not prime, you have to break them down again. If they're prime, what you want to do is circle it. So think about 4 and think about 7. One of those numbers is a prime number. Do you know which one? Okay, if you said 7, you're correct, because the only factors for 7 are 1 and 7. So you circle 7 because it's prime. Now, 4 is not prime, so you have to break it down. What could you break 4 down into? And remember, you're looking for factors that you could multiply by to get 4. So what you're going to choose is 2 times 2. Okay? Now, 2 and 2 is a prime number because the only factors are 1 and 2. There's no other factors, so those are both prime. Okay? All right, so let's look at the other method, the ladder method. All right? So what you start out with is 28. Okay? And you go here and break it down like this. All right. So